All right, Math 9, Chapter 6, here we go. We are talking about equations and inequalities. So we'll talk more about inequalities later in the chapter, but we just got finished talking about linear equations and polynomials. So now we're going to be solving equations. And solving, you'll find out right away here, means that we want to find out what the unknown value is in an equation. So it often includes the variable x, that's most common, but any variable that would be unknown, we're going to solve for that and find out what that actually is. And inequalities are very much the same. Inequalities are a range of solutions. Okay, so if something is less than 5, then there's a range of solutions. There's a whole bunch of numbers that are less than 5. So equal sign is equations, and then a less than or equal to or greater than or equal to, those are inequalities, and you may have seen those before. But let's focus on the first part here, which is equations. So in previous grades, you've learned how to solve one-step and some two-step equations. Hi. So we're going to review some examples of things that you should know how to do, some really basic stuff. So whatever you do to one side of the equation, this is very important when we're dealing with equations. Whatever you do to one side, you also must do to the other side. And I want you to think of an equation as a bit of a balance, okay? So almost like a teeter-totter. You know, like when you guys were young and you played on the teeter-totter? I don't know if that's what you guys call it, but so the teeter-totter is like this, right? You have like a board like this, a big fat board, and you got a handle here, and you got, whoops, you got another handle over here, and then you got, you got somebody, you got Sally sitting over here, hanging on, and legs dangling, and then over here you got, Jimmy or whatever, he's sitting over here too, and he's got his arms there, and he's dangling too. Okay, so teeter-totter. All right, now it's exactly balanced if we're talking about an equation. Okay, this side is equal to the other side. So if Jimmy, and he looks a little bit bigger than, I can't remember what I named her, Sally, but if the teeter-totter like this, if it's exactly equal, then these two are equal. This quantity over here equal to this quantity over here, okay? And it would be the same weight, right? Same mass, same weight, that's equal. So in an equation, you think about that. If I add something else to the equation, okay, so let's say we have another person that's going to sit with Sally. Oh boy, my drawing skills again. So here we go, we got Jimmy, and now it's like this because we've got Sally. Okay. Okay, and then we've got Sally's little sister, okay, is also over here. So she's sitting there too, legs all over the place. Okay, she's hanging on to Sally. All right, so now the teeter-totter is imbalanced, right? So we've added something to one side, and so it's not an equation anymore, it's not equal. So what we have to do is we have to add the same thing to the other side to make it equal. So again, if we had little Sally over here, and then we've got little Sally's twin over here, okay? All right, the drawings are getting really bad now, but then they would be equal again, you see? Okay, everybody see? So whatever you do to one side of the equation, you have to do the other. When we solve for x, we need to, excuse me, we need to isolate for x. So the word you put in this blank, your first blank, is isolate, which means you get x by itself. Get x by itself. Because if we want to know what x equals, let's just find out what x, a 1x, a 1 positive x, what does that equal? And then whatever is on the other side is what x equals. So you want to get x all by itself, which means that it has to be positive, okay? So let's not leave it as a negative. It has to be positive. And the coefficient, the number in front, has to be a 1. So that looks like there's no number in front. So positive and number 1 coefficient, let's say. 1 is the coefficient. Do you remember what the coefficient is? We learned that in chapter 5, I think, right? The number that's multiplied by the variable. And technically, x has to be in the numerator as well, which I think we'll get to when we get to maybe some of the more difficult ones. But you can't have like 1 over x in the bottom of a fraction. That doesn't count. Okay, it has to be x on top. It has to be 1 positive 1x over 1. That's what it has to be. That's technically what it has to be. Okay, x is isolated all by itself. And you'll see as we do more examples here. Okay, so to get x by itself, we perform opposite operations. And that's what you hear me call it all the time, opposite operations. also called inverse operations. Okay, they're also called inverse operations. And the opposite operation for adding is, what is it? Subtracting. The opposite operation for multiplying is dividing, right. So in order to get all of those numbers away from x to the other side to isolate all by itself, we have to kind of peel them off. And we have to do the opposite operation to kind of algebraically or mathematically get rid of them, okay? Send them to the other side. All right, so x minus 3 equals 7. Now, you can do this kind of stuff in your head. These are really, really easy. And so you know right away what x is. You can look at that, and you know right away, some number, when I take 3 away from it, equals 7. X equals 10, easy, right? Let me show you how you would actually show your work to do this properly, because we're going to get into way more difficult ones, and so we need to know how to show our work and do opposite operations. So x is all by itself right here, except we have a minus 3 on the same side of the equation. So I don't like that there. I need to get rid of it. I need to isolate x. So the opposite of subtracting, we said, was adding. So I'm going to add 3 to both sides. So some kind of indication like this is showing your work. So please do that. Just do a little plus 3, plus 3. You do the same thing to both sides, and you show me that you know exactly what you're doing and how you can understand the process. Now we simplify. Again, I like you to work down like this. Don't work left to right. I don't want to read a big math novel, because you will get something messed up if you do that. So don't go left to right. You got to go down. Try and keep everything neat in columns if you can. So this is gone now. Minus 3 and plus 3, that equals 0. So x is now just x plus 0. That's just x all by itself. And then I simplify the right side. 7 plus 3 is 10. Okay? So that's how you show your work, and you do the opposite operations to isolate for x, even in a very simple equation. All right, let's get going a little bit faster here now. So x is by itself here in b, but not exactly by itself. It's got a plus 2 there, so I'm going to do an opposite operation of minus 2. And what I do to one side, I have to do to the other. So in simplifying the left side, I see that plus 2 minus 2 is 0, so those are gone. I'm just left with an x all by itself. And now over here, 5 minus 2 is 3. So if we do a little check for this one as well, 3 plus 2 equals 5. That is totally correct. So let's circle our answers, because you're going to probably do some checks here too. So we'll circle our answers. And the check for A that we didn't do, but is 10 minus 3 equals 7. That is absolutely correct. Okay, opposite operation of multiplying. So x over here is being multiplied by 2. We said the opposite was division. So we divide both sides of the equation by 2. Okay? Everything that's on the one side of the equation, divide by 2. Everything that's on the other side, divide by 2. So divide by 2, divide by 2. Please don't, when you're multiplying, don't use x for multiplying. Okay? Because x is a very common variable. Do not use x for multiplying anymore. I see some of you still doing that. I'm sorry that was okay in elementary school. It ain't not okay here in high school. Okay? It ain't not okay. Double negative, you get that? No, it's not okay to use x for times here, for multiplying. Please don't do it. Also, don't do this division symbol. Don't do it. Okay? Just trust me. Don't do it. You will not be using this at all in grade 10, 11, 12. It's plus you have to do fractions as division, and it's just a lot easier to do over 2 over 2. So this is the division over here, okay? So we're not going to use those ones. 2x divided by 2. Zoom in a bit here on this one again. The 2 and the 2 cancel out. Do they cancel out? Well, they actually simplify to 1. That's what they actually do. So it's 1 over 1 times x, which 1 times x is just x. So sometimes we say cancel out, sometimes we say divide out, okay? And then over here, 10 divided by 2 is 5, okay? So that's our answer. Let's check that. And some people like to check before they circle their answer, which I think is a great idea. So let's check first, then we can circle our answer. So 2 times 5, notice that instead of an x for times, I just use the brackets there. You can also use the dot. Remember the dot? So you can also go 2 times 5. That's not a decimal point. A decimal point is down here. The dot means multiplying. So you can use a dot, or you can just use brackets. 2 times 5 equals 10. That is absolutely correct. We've got the right answer. finally, I think this is finally, yeah, finally before you guys get to practice on your own, x divided by 5 equals 3. So I want to get rid of the divided by 5, and so opposite operation is? Multiply. Okay. So this is where students can this is where it gets a little trickier, okay, just a bit. But watch what I'm going to do. I'm going to do 5, okay, times this, and 3 over here times 5. So both sides multiplied by 5. Now 5 times x divided by 5, these 5s, that's a 5 in the numerator up top, because it's really like 5 over 1, divides with a 5 on the denominator, the bottom. So this really is the same as 5 over 5 times x, you see, like that. So 5 and 5 go. So x is all by itself there now. And 3 times 5 is 15. So we'll check that. We'll say 15 divided by 5 equals 3. That is absolutely correct. 15 divided by 5 is 3. So true. And then we'll circle both these after we've checked them. Okay, any questions at all? Those are pretty simple. We've done those before in previous grades even. Should be pretty easy. Everybody got a 5 out of 5 on that one? Understand it? Can do it? You could teach it to your little brother, little sister there. Okay, good. Good. You should know it pretty well. All right, so I'm going to let you try these for a bit. I'm going to give you a few minutes. I want you to try these ones. Do them on your own. We have some opposite operations to do. They're very much like the ones I just did. So go ahead and take a few minutes, get through as many of these as you can. We will move on in a few minutes whether you're done or not. The rest that you don't get done, no problem. You can just finish a little bit later. But at this point, go ahead and work on these ones right now. Okay, so I'm going to do some of these real quick here on the board. So I'm going to subtract 4. Subtract 4, so that's x equals negative 11. That should be that one there. I'm going to add 6. Add 6, that's going to be x equals 21. So just double check my work there, please. Divide by 4, divide by 4. That's going to be m equals 3. Divide by, here's a tricky one. You have to divide by negative 2 to get positive x, right, in the end. So that's going to be x equals negative 8. I'm not sure how you did with that one, but if you got that, great. 3 times, both sides. The 3's cancel out. P is negative 6 here. And finally, multiply by 6 as well, both sides. The 6th and 1/6 multiply to a 1. X equals 24. Okay? And you can check those as well. I should check my work as well. Yeah, looks good. Anybody else? Got any questions about that? Okay, everybody understand? All right, so it took me literally 45 seconds to do all these, and I showed all my work. Okay, so it won't take you 45 seconds. It might take you a little bit longer, but it's not going to waste your life, I promise. Showing your work and making sure everything's good. Now, if you check these answers, it can take you a little bit longer, but good idea to do. Negative 11 plus 4 is negative 7. That's absolutely correct. 4 times 3 is 12. That's absolutely correct. Negative 6 divided by positive 3 is negative 2. That's absolutely correct. So check your answers as well. Any questions? Good? Easy? Easy? All right. That's what I like to hear. Easy. It's 5 out of 5, Mr. Maxwell. Nicely done. Okay. So that's basically review, though. Yeah, so that's what you should know. It should be 5 out of 5 right now. So let's move on. Things are going to be just marginally more difficult here, I think. Not too bad. So let me just zoom in here a bit. I still feel like this is a bit too small. Okay, get right to the edge there. Okay, so example 1, solve these examples using inverse operations, show all of your steps. Okay, so x plus 2 equals negative 9. Again, we're just training ourselves here. The operation on x is, so you're going to put right here, you're going to put adding, because we're adding a 2, okay? So you're going to put adding. Even better, let's say adding 2. So what's the inverse or opposite operation of adding is subtracting 2. Now, you can make a abbreviation for subtracting, SUBTR. I'm totally fine with that. That's what I do. So let's subtract 2, okay? And you can say add 2 as well. So add 2, subtract 2. All right. So let's do it. Minus 2, x equals, these 2 are gone. Negative 9 minus 2 is negative 11. Verify. That's our check over here. So I'm going to put negative 11, my proposed answer, in for x. and I'm going to get negative 11 plus 2 is negative 9. Let's see if that works. Well, I'm going to draw a little number line because some of you might like to do that. I'm going to start at negative 11, and I'm going to add 2 from negative 11. That's going this way, and so that gets me to negative 10, and then negative 9. Here's 0 over here. That is absolutely correct. If you don't like integers still, adding and subtracting integers, think of the number line, draw a number line. Okay, it's okay if you have to do that. The more practice you get, you won't have to draw the number line anymore. You won't have to use those kind of methods. It'll be in your head. But for now, if you struggle with that, draw a number line. I still, honestly, sometimes when I'm doing big operations, I picture a number line in my head, honestly. For lots of calculus and math, as x approaches infinity, I think of the number line on my paper. Like, it's just like, what is the graph doing as x approaches infinity? This is something that you'll have to do later, but I still think of a number line in a sense of the x-axis. I picture that in my head. So don't feel bad if you have to do that, okay? All right? All right. You guys are going to be such great calculus students. I can't wait to have you. Oh, it's going to be so good. Okay, all right. Yeah, train them up. Okay, the opposite operation for y here is, the operation is subtract. So subtract 2.4, and the inverse would be add 2.4. Awesome. So let's add 2.4. Should I do it to one side only, or should I do it to both sides? What do you think? Both? Oh, wow. He's pretty smart. Okay, so let's add to both sides. So y equals, what's 6.5 plus 2.4? Try not to do this on your calculator. If you can do it in your head, exercise, okay? You can check in your calculator if you want. 6 and 2 is 8. 0.5 and 0.4 is 0.9, right? So we got 8.9. Okay, you good with that? 8.9. I think I like it. So verify. 8.9 minus 2.4 equals 6.5. Okay, now if you want to check that in your calculator because those numbers, those decimals are just too much for your brain right now, that's totally fine. Check them, make sure that this equals 6.5. But yeah, 8 minus 2 is 6, 0.9 minus 0.4 is 0.5, so we're good to go. Okay? You guys look like you're doing pretty good. We're doing pretty good? Yep. All right, let's keep it rolling. C, write the equation and solve. 3 times a number is 3.6. Okay, so now here is where we create an equation to match the word sentence, okay? The first step in being good at problem solving and word problems in math is to do this sort of thing. Take English words, put it into math symbols. So, 3 times a number, okay? 3 times a number. Well, first of all, I know what 3 looks like. I know what times looks like. That's multiplication. And a number is the unknown sort of variable. So you can let, excuse me, a number, an unknown number, equal really any variable that you want. It can be x, that's pretty common. If it says a number, you could write it as n. That's meaningful, right? So I'm going to do that, a different variable. I'm going to do 3 times a number. I don't have to do any kind of multiplication symbol here. I can just write this 3 and the n right beside each other. That's 3 times n. And then I have is negative 3.6. So the is the equal sign. You see that? That's what it is. It is negative 3.6. So 3 times the number is negative 3.6. How are we doing with that? You guys okay with that? Okay. It says write an equation. So good, we got that in red. Let's solve now. Okay, solve. The operation on n is multiplying, right? M-U-L-T dot, multiplying by 3. So the inverse operation is dividing by 3. So let's divide by 3. I'm going to show that by just doing this. Divide by 3, divide by 3. 3's are gone. I have n all by itself. 3.6 divided by 3. Okay. Think about, well, you guys might know what 36 divided by 3 is. Do you know what 36 divided by 3 is? What is it? It's 12, right? 3 times 12 is 36. So guess what? If we have 1 decimal place over, our answer also has 1 decimal place over. So 3 times 1.2 is 3.6. So we're going to have a negative because we have a negative divided by a positive number. So that's a negative 1.2. And then, of course, you can check that on your calculator if you want. 3 times negative 1.2 should equal negative 3.6. We're good. Okay. Why don't you try D? You try D by yourself, because you guys are looking pretty confident. Try D by itself. A number divided by 4 is 1.5. Write the equation and solve that. I'll give you a minute to do that. Okay, let me walk you through my solution here. So a number divided by 4 is 1.5. That's n divided by 4 equals 1.5 in red there. To solve the equation, the operation happening to the variable there is dividing, so we're going to multiply. And we multiply both sides of the equation. Every term on both sides. We just have one term on each side right now. Just have one term, so it's easy. Multiply both terms by the number. But we might have to multiply the whole side, like all the terms on one side of the equation. That's coming later. So you multiply everything by 4. And the 4's cancel out here, divide out. N equals 6. 6 divided by 4 to check. 6 divided by 4 is 1.5. You do it on your calculator, you get a big check mark there. Also, you could write 6 over 4 as a reduced fraction of 3 over 2. And 1.5 as a fraction is also 3 over 2. So that works. Okay. All right, are you guys ready for two-step dual operations here? 2 steps? 2 steps are easy. You just do one at a time. No problem. The only thing is, you have to be careful the order in which you do these, okay? And I've mentioned this, I think, before, but now is a good time to redo that. So the order of operations, you remember, are BEDMAS, okay? Order of operations are BEDMAS. That is when you are evaluating a string of, adding, subtracting, multiplying, dividing. If you're evaluating this to one answer, that's the order in which you do those operations, BEDMAS. I'll write that down, BEDMAS, so you should know that. But when you're solving, okay, solving is BEDMAS in reverse because it's opposite operations. It's inverse operations. So, B, E backwards, D, M, A, S, or SAMDEB. SAMDEB, BEDMAS. It doesn't roll off the tongue quite as easy as BEDMAS, but SAMDEB. So what you do is when you're deconstructing a side, when you're trying to pick out your variable, you work from left to right in reverse or opposite operation order. No problem. So we do subtraction or addition first. So the operations on P are subtraction and multiplication. Okay? Now, the order which you mentioned, that doesn't matter. The order in which we actually peel those off or take those away does matter. Okay? So I'm going to say the operations are, I'm going to write multiplication first, and then I'm going to do subtraction, okay? The inverse operations would be then adding, so the opposite of subtracting, so adding first, and then dividing, okay? So this is how this turns out. So I'm going to look at, here's the multiplication for times 3, and here's the subtraction minus 4. So I'm going to add 4 to both sides. Add 4. Okay. These 4s are going to cancel out. I'm going to be left with 3p. So you do one at a time. 3p equals 9. Okay? So it's 2 steps. You do your inverse operations in the inverse order. And then now I divide. So now I divide by 3. And I get P equals 3. Okay, to check or verify, I would suggest you always do that either in your head if you think it's reasonable, on your calculator if you need to, show it here on the paper is best. 3 times 3 minus 4 is 5. Well, that's 9 minus 4 is 5. You can stop whenever you're totally convinced that that is the right answer. So 9 minus 4 is 5. So P looks to be our correct answer. You guys good with that? So P equals 3. Yeah? All right. Let's do one more together, and you can take this nasty one with the decimals. Okay. So this one, operations are multiplying and adding. So we're going to do subtracting and dividing. The opposite operations in opposite order. So subtracting first, so minus 7 minus 7. Those are gone. 2a equals 12 minus 7 is 5. Should be 5. Now we do dividing next. So divide by 2. Divide by 2. And a equals 5 over 2. Or a equals 2.5 as a decimal. So 2 times 5 over 2 plus 7 equals 12. To check, right? 2 times 5 over 2, those 2's cancel. We get 5 plus 7 equals 12, and that is absolutely correct. So here you go. And it doesn't matter right now if you use fractions or decimals. I imagine decimals might be a little bit easier. Some of you might be referring to your calculator to do this. It's fine. Later, as we move through math, you're going to have to get more and more comfortable with fractions. But right now, I'm fine either way. Okay? All right, so with the decimals, and yes, you can use your calculator if you wish. Go ahead. I want you to try and do G by yourself here now, okay? Fill in the blanks over here. I guess you don't have blanks in your paper, do you? Sorry, but fill in the blanks over here, whatever. Your operations, there should be 2 on each. And then go ahead and solve for n there. Okay, so let me run through the answer with you. So we have... the operations are dividing and adding, and I'll add divide by 3 because that's what we have here, and adding 1.9. So yes, this is a positive 1.9. It's added to this term, so we'll say adding, right? The inverse would be subtract by 1.9 and multiply by 3. So let's subtract by 1.9 first, which is here and here. I get n over 3 all by itself. 6.8 minus 1.9 is 4.9. Okay. And then multiply by 3. So both sides multiply by 3. The 3's cancel out here. And we just get n equals 3 times 4.9 is 14.7. Okay. Yeah, so this is the correct answer. You can use your calculator if you wish. Yeah, you can use your calculator if you wish to solve for these. Okay. Any questions? All right. Okay, so next page, try these, solve and verify. Okay, so we have A and B here. I will do the first one for you, and then I'll let you do the second one. So we have x in the denominator here. So this is another layer of trickiness. Remember, we have to have x in the numerator. It has to be by itself with a positive 1 coefficient in the numerator. So it's in the denominator right now. So here's where I want to try and bring it up to the numerator. So do you remember when you have an equal fraction, you can do something called cross multiplying, dividing? Remember that? So let me talk to you about cross multiplying and dividing. Well, it's basically a 2-step solving of an equation just like we're doing. X is being, right now, X is on the bottom end here of division. So we need to multiply both sides, and this is the tricky part. We need to multiply both sides by x, and that is, in a sense, the same as cross multiplying. Okay, so write this down. It's very much the same as cross multiplying. Multiply both sides by x. And you say, Mr. Maxwell, I don't want to get rid of x. I want to find x. Well, you kind of want to get rid of x in a sense that you don't want it in the denominator. So this brings it up to the numerator. Do you see that? So cross multiplying, you would just go ahead and you would do this. So you actually have 4.2 equals 3x. Everyone see that? So now x is in the numerator. It's in the, because each of these would be, you can envision each of these being over 1. So x is in the numerator, perfect. Now all you do is get rid of the 3. The 3 is being multiplied, so I'm going to divide both sides by 3. So I have x over here equals, what's 4.2 divided by 3? 42 divided by 3, let's see. 3 times 1 would be 3. I need another 1.2. Okay, so, sorry, what did I hear? 1 point, 2 point, 1 point? 1 point what? 4. Okay, so times 1 would be 4, times 0.4 would be 1.2. So 3 plus 1.2 is 4.2. So 1.4, yeah, is correct. Okay, very good. So let's check that out. So if we had original equation now, 4.2 divided by 1.4 equals 3. Do that on your calculator if you wish. That you should get 3 equals 3 there. Okay, so we got to bring the x up. Yes, you do need to kind of eliminate the x from the denominator. So go ahead and do B on your own there. It's very, very really exactly the same as A. So go ahead and do B by yourself. See if you can do it. All right, take a look up on the screen there. Frozen. Take a look up on the screen and check your answer with mine. So again, we need to get the x out of the denominator. So we'll multiply both sides by x. That gets rid of the x here. 0.5x equals 2. Divide by 0.5. So remember, 2 divided by 0.5, that's actually 2 divided by 1/2, or 2 times 2 over 1. So that makes it bigger. When you divide by a decimal that's less than 1, the answer is bigger. So that's 4. And 2 over 4 equals 0.5. Well, I can reduce 2 over 4 to 1 over 2, and 0.5 can also be written as 1 over 2. So those are the same. Questions? All right, great. We got a few more examples here to do before we're done this part of the lesson. So example 2, solve and verify equations can also contain brackets. Okay, if you remember from the unit on polynomials, this requires us to use the distributive property. So we have to multiply into the brackets to each term. So every term in the bracket is multiplied by the number that's in front. Okay, and the number could be a decimal or a fraction as well. So we do need to eliminate brackets, okay, and that's what I kind of think of. Try and eliminate brackets in order to simplify. So eliminate brackets here by multiplying. Okay, by multiplying. Eliminate brackets. Yep. If you must. Yep. So 2 times 3.7 is what? 7.4 plus. So 2 times 3.7. You write that down, and then 2 is also multiplied by the second term here is a positive x, or a plus x. So that's plus 2x. So you expand that, distribute that too. Equals 13.2. And then all of the other things we talked about today kick in. So we'll subtract 7.4. We'll have 2x equals 5.8. 13.2 minus 7.4 is 5.8. Divide by 2. We get x equals 2.9. And I'm going a little bit quicker here because you can use your calculator if you want to do this. All the process is the same. Okay, distributive property. I'll do another one with you as well. Any questions on that one? Okay, so for B, we have to distribute 1.5 into the brackets. So I'm going to rewrite 6 on the left side because I'm not touching that. So rewrite it. 6 equals 1.5 times x is 1.5x. 1.5 times a negative 6. Think about this minus as a negative, and then that helps you. So that's going to be minus 6 times 1.5. That's 6 plus half of 6. That's 6 plus 3. So that's going to be 9. Okay. Any questions about that? Multiply in. Do your little arrows or little lines at least. Show me you're multiplying in. Takes half a second. Add 9 to both sides. Add 9, because again, here's the x. I'm trying to peel everything else away. So I add 9. That's going to be 15 over here. 1.5x. Divide by 1.5. 15 divided by 1.5. X equals 10. Okay. Any questions on the distribution? Does that look reasonable? Any questions at all? Okay. I know this, maybe a lot of information. A lot of this is actually review, so it's not a whole bunch of new stuff. But last question before I set you up with your assignment here. So on a test, it's a different kind of question. We got to spot the error here. So a student solved a question like this on the test. Were they correct? Yes or no? So let's see. It's 3 times x minus 5 equals 2. So you should be distributing the 3. 3 times x and 3 times negative 5. Looks like they're doing that here. 3 times x is 5. And then, I see something wrong on the very first line of work here. Do you guys see it? Okay, what did they do they shouldn't have done? Okay, so they distributed this 3. You see this? They distributed the 3 all the way to the other side of the equation. That doesn't work. You can't do that. No. So only into the brackets which immediately follow the number. So at the end of the bracket, you have to stop your distribution. Got it? Okay, so that is incorrect. So let's correct it. So on the side, let's correct. I'm not sure if they did anything else wrong, but we'll see. So 3 times x minus 5 equals 2. This should be 3x minus 15 equals 2. Not 2 times 3. We need to add 15 here to get 3x, because those 15s are gone, equals 17. Now I need to get rid of the 3, which is multiplied, so let's divide. X equals, can't simplify 17 over 3, doesn't look like, so 17 over 3 is just going to have to remain a decimal, remain a fraction. If you want to write it as a decimal, you can, but fraction is just as good. Or x equals, you can just do that on your calculator. Wow. What's the number that 3 multiplies to get to that's just under 17? What's the closest one? Yeah, 15, right? So this is going to be x equals 5 groups of 3, and with 2 left over, right? So 5 and 2/3, that's another way you could write that, right? Or, do you know what 2/3 is as a decimal? Anybody know that? Yeah, 0.6 repeating, very good. So this could be 5.67. Very good. Okay. All right. Any questions at all? That's kind of the first part of 6.1. We're going to split 6.1 into several parts. So, any questions? All right. So please make sure you've got all the questions finished on your sheet. I think I kind of went over. I think I went over all of them with you today. So, yeah. If you have any questions about anything today, you can let me know. I will hand out your assignments, so I'm going to give you some handout assignments. Those assignments are on the website too. If you happen to lose yours, you can reprint them off. So if you do lose your notes or your sheets, go to mrmathwell.com, courses, go down to Math 9, or you can hit the courses page. And what you'll see is down here in Chapter 6, so all the way down to Chapter 6, you will find, where are we? I'm just working on this page here. So here's your notes. Right here, should show up. Come on, there's your notes anyways. So you can print off your notes, and you can print off these worksheets right here. You should have a display there, but anyways, so Chapter 6 notes and worksheets, that's where you can print those off.